Hey Velammal Nexus students, this is SanmugaPriya. Today we are going to discuss about big picture on speech recognition with deep learning. And moreover, machine learning is fun. So let's enjoy machine learning. What is speech recognition? Speech recognition is invading our lives. It's built into our phones, our game consoles, and our smartwatches. It's even automating our homes. Amazon Echo is a magic box. You can order pizza, weather report, or you can buy trash bags just by keeping out loud by saying, Alexa, order a pizza. So what is speech recognition? Speech recognition software is a program trained to receive the input of human speech and decide it and turn it into a readable text. This software filters words, digitize them, and analyze the sound they are composed of. The digital representation of these sounds undergo mathematical analysis to interpret what is being said. Speech recognition applications include call routing, voice dialing, voice search, data entry, and automatic detection. Speech recognition or speech-to-text is the ability to machine or program to identify words spoken aloud and convert them into readable text. Speech recognition software has a limited vocabulary of words and phrases, and it might only identify these if they are spoken very clearly. More sophisticated software has the ability to accept natural speech, different accent and languages. And speech recognition incorporates different fields of things. Speech recognition is used to identify words in spoken language, and voice recognition is a biometric technology used to identify a particular individual's voice or speaker's identification. Let's talk about history of speech recognition technology. As with any technology, what we know today has to have some of somewhere, sometime, and someone. In fact, the first ever recorded attempt at speech recognition technology dates back to 1000 AD through the development of an instrument called supposed to answer yes or no to direct questions. Though this experiment didn't technically involve voice processing in any form, the idea behind it remains to be a part of the foundation of speech recognition technology, using natural language processing as an input to trigger an action. Centuries later, Bell Laboratories worked to develop Auditory, a system able to recognize the number 1 to 9 spoken by a single voice. Later, IBM developed a device that could recognize and differentiate between 16 spoken words. That's great, right? These successes brought about higher prevalence of technological companies focusing on speech-related technologies. Indeed, even the Department of Defense want to get into those actions. Slowly but surely, developers moved towards the goal of enabling machines to understand and respond to more and more of our verbalized commands. The history of speech recognition technology has been a long and winding one. Nevertheless, today's speech systems such as Google Voice, Amazon Alexa, Microsoft Cortana, and Apple's Siri would not be where they are today without the early pioneers who paved the way. Thanks to the integration of new technologies such as cloud-based processing as well as ongoing data collection projects, these project systems have continuously improved their abilities to hear and understand a wider variety of words and languages and accents. At this rate, it seems scientific writers' prediction of the future aren't as far off as we might think. So let's see how speech recognition works. It's gonna be interesting. Speech recognition works using algorithms through acoustics and language modeling. Acoustic modeling represents the relationship between linguistic units of speech and audio signals. Language modeling matches sounds with the word sequence to help distinguish between words that sound similar. Often hidden Markov models are used as well to organize temporal patterns in speech to improve accuracy within the system. This method will randomly change systems where it assumes that future states do not depend on past states. Other methods used in speech recognition may include natural language processing, that is NLP, an emerging technology in real world, or called n-grams. NLP makes the speech recognition process easier and take less time. N-grams, on the other hand, are a relatively simple approach to language models. They help create a probability distribution for a sequence. More advanced speech recognition software will use AI and machine learning. These systems will use grammar, structure, syntax as well as composition of audios and video signals in order to process speech. Software using machine learning will learn more the more it is used, so it may be easier to learn concepts like accents, the words. Let's see about speech recognition software and how it is related to deep learning. Traditionally, speech recognition model relied on classification algorithm to reach conclusion about the distribution of possible sounds for a frame. Today, thanks to deep learning, neural networks are used to perform isolated word recognition and phoneme classification and audiovisual speech recognition, speaker adaptation, and audiovisual speaker recognition. Speech recognition software uses natural language processing and deep learning neural networks to break the speech down into components that it can interpret. It converts these components into a digital state and analyzes the segments of the content. The software trains on a dataset of known speak words or phrases and makes prediction on the new sounds, forming a hypothesis about what the user is saying. It then transcribes the spoken word into text, that is, speech to text. However, recognizing sound is not enough. To be useful, speech recognition software needs to be able to know, for example, the difference between proper name and regular words. For example, cook in James Cook is a name. And to differentiate between the homophones. Example, the words with the same pronunciation but with the distinct meaning. Thus, a challenge of speech recognition is creating an intelligent process not only to hear the speech but also to interface and reason over the source of knowledge and hierarchical relationship that makes idea in a real world. Okay, now let's go through what is voice recognition and how does voice recognition work. Surrounded by smartphones, smart cars, smart home appliances, voice assistants and more, it's easy to take for granted like how speech recognition technology actually works. Why? Because the simplicity of being able to speak to digital assistant is misleading. Speech recognition is actually incredibly complicated even now. Think about how a child learns a language. From day one, they hear words being used all around them. Parents speak to their child, and although the child doesn't respond, they observe all kinds of verbal clues, intonation and inflection and pronunciation. Their brain forms patterns and connection based on how their parents use those language. Though it may seem as humans are hand-wired to listen and understand, we actually being trained our entire lives to develop this so-called natural ability. Speech recognition technology works in essentially the same way. Whereas humans have refined our processes, we are still figuring out the best practices for the computers. We have to train them in the same way our parents and teachers trained us. And that training involves a lot of innovative techniques and thinking and manpower and researches. So let's go through the application of speech recognition briefly. The most frequent application of speech recognition within the enterprise include the use of speech recognition in mobile devices. For example, individuals can use this functionality in smartphone for call routing, speech text processing, voice dialing, and voice search. A smartphone user could use the speech recognition function to respond to a text without having to look down at their phone. That's cool. Speech recognition on iPhones, for example, is tied to another function like keyboards and Siri. If a user adds a secondary language to their keyboard, they can then use the speech recognition functionality in the secondary language as long as the secondary language is selected on the keyboard when activating the voice recognition. To use other functions like Siri, the user would have to change the language settings in their phone. Speech recognition can also be found in word processing applications like Microsoft Word, which we all use, and where users can dictate what they want to show up as text. Which voice assistant is the best? By now, we have all heard of speech recognition system. They have penetrated the tech ecosystem and enrooted to become the de facto means communication between humans and technology. Voice input is simply the more efficient form of computing, says Mary in her annual Internet Trends report. Humans can speak 150 words per minute on average, but they can only type 40. Goodbye texting and pushing buttons, we are simply too busy for all that now. What's kept speech recognition from becoming the dominant form of computing as of yet is unreliability. Relational accents and speech impedance can throw off word recognition platforms, and background noise can be difficult to penetrate. Not to mention multiple voice input. In other words, simply recognizing sound isn't quite enough. To have any level of effectiveness, these speech recognition systems have to be able to distinguish between the homophones, words with the same pronunciation but different meaning, is the homophones, to learn the difference between the proper names and separate words. Tim Cook is a person, not a request to find a cook named Tim, and more. After all, speech recognition accuracy is what determines whether these voice assistants can't live without feature. This is, of course, begs the question as to which voice assistant currently out on the market is the best. in terms of speech accuracy, innovation and usability and cohesiveness with the other smart systems. Let's see those examples which use voice assistant in their application. First, we see Apple's Siri. Apple Siri was the first voice recognition assistant created by mainstream tech companies debuting back in 2011. Since then, it has been integrated in all iPhones, iPads, and the Apple Watch and the HomePod, Mac computers, and Apple TV, and so on. Via your phone, Siri is even being used as the key user interface in the Apple's CarPlay system for automobiles as well as the wireless AirPod earbuds. With the release of Siri Kit, a development tool that lets third-party companies integrate with Siri and HomePod, Apple's own attempt at intelligent speaker following the success of Amazon Echo and Google Home, voice assistant's ability become even more robust. Siri is with you everywhere you go, on the road, in your home, or for someone literally on your body. This gives Apple a huge advantage in terms of adoption. Although Apple had a big head start with Siri, many users expressed frustration at its seeming inability to properly understand and interpret voice commands. Naturally, being the earliest quite often meaning receiving most of the flake for functionality that might not work as expected. But even Siri remains notorious for misunderstanding voice commands, even going so far as to respond to a request for help with alcohol poisoning by providing list of nearby liquor stores. If you ask Siri to send a text message or make a call on your phone behalf of you, it can be easily done. However, when it comes to interacting with third-party apps, Siri is a little less robust compared to its competitors. Working with only 6 types of apps, ride-hailing and sharing, messaging and calling, photo search, payments, fitness, and auto-photo systems. Why? Because Apple is betting that customer will not use voice commands without an experimenting similar to speaking with a human, and so it is limiting what Siri can do in order to make sure it works well. Now an iPhone user can say, "Hey Siri, I would like to ride to the airport," or "Hey Siri, order me a car," and Siri will open whatever ride service app you have on your phone and book the trip. Focusing on the system's ability to handle follow-up questions, language translation, and revamping Siri's voice to something more human is definitely helping to iron out the voice assistant user experience. In addition, Apple rules over its competitors in terms of availability by country and thus in Siri's understanding of foreign agents. Siri is available in more than 30 countries and 20 languages, and in some cases, several different dialects. Google Home, by comparison, is available in only 7 countries and can only speak 4 languages fluently: English, German, French, and Japanese. Though it does support multi-version of some of those languages, Alexa, on the other hand, can only manage English, that is US and UK and German. Let's see about Amazon Alexa. Alexa is one of the most popular voice assistants out there today. Whereas Apple focuses on perfecting Siri's ability to do a small handful of things, pegged Amazon's word recognition rate as being a shade behind other voice platforms. The good news is that Alexa adapts to your voice over time, offsetting any issues it may have with your particular accent or dialect. With 30,000 skills and growing, Alexa certainly output Siri like Google Voice and Cortana combined in terms of third-party integrations. With the intensive to add voice to your big idea and reach more customers. That is, not to mention the ability to build for free in cloud, no coding knowledge required. It's no wonder that developers are rushing to put content on the Skills platform. Some can't help but draw similarities with Apple's App Store, which also attracted the attention of developers rushing to the any content on their platform, regardless of whether or not that content was actually valuable. Another huge selling point for Alexa is its integration with smartphone and smart home devices such as cameras, door locks, entertainment system, lighting, and their home theaters, ultimately giving users absolute control of their home, whether they are causing up on their cough or on the go. With Amazon's Smart Home Skill, another third-party development tool similar to ASK, you can enable customers to control their connected devices from 10 of millions of Alexa-enabled endpoints. When you ask Siri to add something to your shopping list, she can add it to your shopping list without actually buying it for you. But Alexa, however, goes to a step further. If you ask Alexa to reorder your rubbish bags, she will just go through Amazon and order them. In fact, you can order millions of products off Amazon without even lifting a finger, a natural and unique ability that Alexa has over its competitors. Now, let's talk about Microsoft's Cortana. Based on 26th century artificial intelligence character in Halo video game series, Cortana debuted in 2014 as part of Windows Phone 8.1, the next big update at the time of Microsoft mobile operating system. Microsoft has since announced in late 2017 that its conversational speech recognition system reached a 5.1% error rate, its lowest so far. This surpasses the 5.9% error rate reached October 2016 by a group of researchers from Microsoft Artificial Intelligence and Research, and its accuracy on par with professional human transcription who have advancements like the ability to listen to text several times. In this race, every inch counts. When Microsoft announced their 5.9% accuracy rate in late 2016, they were ahead of Google. However, fast forwarding a year puts Google ahead, but only by 0.2%. While percentages and accuracy rates are important, Cortana differentiates itself from other voice assistants by actually being based upon real human personal assistants. Rival services dig deep into the data from devices you search history, cookies, and you may have left behind throughout the internet. While that's often useful, it can also be irritating in the form of non-stop notifications or just plain frightening that a smart system can know so much about you. Well, we have all watched 2001, A Space Odyssey, where the mother of all sentient computers, HAL 9000, goes on a killing rampage with its unblinking red eye and smooth as butter robotic voice. To avoid this, Microsoft spoke to a number of high-level personal assistants, finding that they all kept notebooks handy with the key information of that person they were looking after. It was that simple idea that inspired Microsoft to create a virtual notebook for Cortana, which stores personal information and anything that's approved by Cortana to see and use. It's not a privacy control panel, but it definitely gives you a little more control over what Cortana does and does not have access to. For instance, if you are not comfortable with Cortana having access to your email, your notebooks is where you can add or remove access. Simple. Another standout feature, Cortana will always ask you before she stores any information she finds in her notebook. Microsoft has also worked closely with Halo developers on iLink visual elements as well as with voice actress Jen Taylor for Cortana's voice. These elements truly bring Cortana to life and prescribes a personality and emotion to the system that it may not have had without the association. Of course, Cortana's personality shines through in daily use as well. Similarly to Google Assistant and Google Search, Cortana has support from Microsoft's Bing search engine, allowing the voice assistant to chew through whatever data it needs to answer your burning questions. And similarly to Amazon, Microsoft has come out with its own home smart speaker, Invoke, which executes many of the same functions that their rival device do. Microsoft has another huge advantage when it comes to market research, with Cortana being available on all Windows computers and mobiles running on Windows 10. Let's talk about Google Assistant. One of the most common responses to voicing a question out loud these days is LMGTFY. In other words, let me Google that for you. It only makes sense that the Google Assistant provides when it comes to answering, that is, understanding all the questions its user may have. From asking for a phrase to be translated into another language to converting the number of sticks of butter in one cup, Google Assistant not only answers correctly but also gives some additional context, that is, cites a source website for the information. Given that it's backed by Google's powerful search technology, perhaps it's an unsurprising caveat. Though Amazon's Alexa was released 2 years earlier than Google Home, Google has made great strides in catching up with Alexa in every short time. Google Home was released in late 2016 and within a year had already established itself for the most meaningful opponent to Alexa. Most recently, Google also announced some news. Key partnerships with companies include Lenovo, LG, and Sony to launch a line of Google Assistant powered smart displays, which once again seem to echo the likeness of Amazon's Echo Show. Where did we come from? Where will we go? Speech recognition has indeed come a long way over the last decade, from the 1000 AD Magic 8 ball to today's land grab in the voice technology market. The intense level of competition we are seeing between these tech giants in the industry and the increased prevalence of companies jumping in create content in the space suggests that we still have a long road ahead of us. So, we are going to show how the Teachable Machine is used for audio. So, in Teachable Machine, I am going to record the sound, different sounds and the background noise. So, I tried a sound classifier and import the machine learning model in p5.js, or you can export a model in any format. So, first, how can I train the classifier? First, we need to record the background noise. So, add the audio samples you need to take 20 minimum samples. Just click on the mic and you can record the background noise. Just click on that button and your background noise is noted. So it is recording your background noise. So you need to click on extract sample. So minimum 20 samples is taken. Now you can rename it as clap and record the clap sound. And click on extract sample. Now again you need to click on record and again extract the sample. Again record 2 seconds until 8 minimum samples you need to take. Finally extract all the samples, so 8 minimum samples are required. If you want, you can add another class like whistle or your voice. Now I'm just adding clap and background noise and I'm training the model. Now the background noise and the clap audio is fed into the training model. So is this a regression or classifier? This is a classification problem because we have by class 0 and 1. 0 is background noise and 1 is clap noise or audio. Both the inputs are fed into the training model and then you can preview. So let's check. So if I speak, that is a background noise. Can you observe that is a background noise? Let's check for clap. If I clap, the clap label should be 100%. Can you able to classify? So the model is able to classify the background noise and the clap sound. So this is a audio classifier by Teachable Machine. You can try at your home and enjoy machine learning. Thank you.